What weighs more, a pound of lead or a pound of feathers? I'm sure we have all heard this trick question at some point. It is meant precisely to trick you or trick people into thinking that the lead is going to be heavier because it has a higher density. So usually you think about feather as something light, lead as something heavy. So it is quite normal to think, if you haven't really studied much physics, oh, lead is probably heavier, so just go for that. It turns out it's a trick question. They're supposedly the same. However, I would like to challenge that thought because of the following thing. Usually, sure, you say a pound of lead is going to have the same weight as a pound of feathers because they have the same mass, they're both on the earth, so they will have the same force attracting them to the earth, and that would be correct. But there is something that this question does not take into consideration. It is that in the earth we have an atmosphere and there's air. So this means that there's going to be a buoyant force acting both on the kilogram of lead or the pound. I'm going to be from now on talking about kilogram because pound is kind of it's not an SI unit, and I really like the international unit, so I'm going to go with kilogram, even though it's not the same as a pound, but the same principle is going to apply to both. So let's say we have this kilogram of lead. Because lead has a higher density, it's going to need less space to have this kilogram of mass. So this are going to be our lead. However, our feathers will need a much bigger volume in order to have the same 1 kilogram of feathers. So this means that the feathers will displace a larger volume of air than the lead, and because of this reason, there's going to be a higher buoyant force acting on the feathers than on the lead, and for this reason, the feathers, the 1 kilogram or pound of feathers, obviously kilogram and pound not the same, but you know what I mean, this 1 kilogram of feathers is going to be actually lighter than the kilogram of lead. So I would like to just prove this quite quickly. So what we're going to do is we're just going to see what is the effective weight of each of these bodies. Now remember, the weight is just going to be the mass of the object times the acceleration of gravity. That's what we usually see. However, now we have to take into consideration the buoyant force acting on each body. So let us do this now, because this buoyant force is going to make this object lighter. That's why it's subtracting. This is, by the way, in case you're curious, this stems from Archimedes' principle. This is usually used in fluid problems, usually in high schools, a little bit in college too, if you see a little bit of this topic. But well, so let's take a look at the weight of the lead. Now, this is going to have, it's 1 kilogram, we said, so the mass is going to be 1 kilogram, and the acceleration is going to be around 9.8. This looks more like a G, but I promise it's a 9 meters per second squared. Okay, so there's this product, and there's the buoyant force of the lead. And now for the feathers, it's also going to be 1 kilogram times the same 9.8 meters per second squared, but this buoyant force is going to be different. So let us calculate each of these buoyant forces. Now the buoyant force is just going to be equal to the weight of the fluid displaced. So this is basically going to be mass times g, but this is going to be of the fluid, this fluid, which is just air. So I guess I can just put an A. And since we don't really know the mass of the air, we can rewrite it, considering that the density of the air is just going to be the mass of this air that is displaced divided by the volume of our object. So in this case, this is going to be the buoyant force for lead. So this is going to be then, instead of mass, we can use this formula multiplying by the volume. So we get the volume of lead times the density of the air times g. Okay, and in the case for feathers, we just get the buoyant force of feathers. It's just going to be, now using the same principle, the volume of the feathers times the density of air times g. Now you can immediately see that because these quantities are basically the same except for this volume part, and the volume of the feathers is going to be greater, the buoyant force on the feathers is going to be greater, and because the buoyant force is subtracting from the total weight, the apparent weight is end up going to be less for the feathers than for the lead, but we're going to show it anyways. So now let's just go ahead and calculate each of these. Now the volume of lead is something that we don't know, and it's actually going to be a problem for both parts. But using the same formula, we can see that the volume for lead or for feathers is just going to be the mass of this object, in this case of lead, divided by the density of lead. So replacing that, we can just get that the mass that we have of lead, which is just 1 kilogram, divided by the density of lead, which is well known, times the density of air times g. This is going to be our buoyant force. Now I looked up these values. Now, well, the mass of lead we said is just going to be 1 kilogram. I'm going to omit the units because I'm going to just put newtons at the end. Okay, so it's 1 kilogram divided by the density of lead, which is about 11.34 grams per centimeter cubed, but the units are going to cancel out with the density of the air, which is also in grams per centimeter cubed, and that is 0.0012. And this whole thing is also multiplied by 9.8 meters per second squared. So this just ends up being newtons. So when we multiply this, we get 0.0012 times 9.8 divided by 11.34. So we get that this buoyant force on the lead is going to be 1.04 approximately times 10 to the minus 3 newtons. And in the case of the feathers, we can do exactly the same. So we get this mass of the feathers divided by the density of the feathers times density of the air times g. Now, because feathers are mostly keratin, I used that value for the density. In either case, even if that weren't exactly the density, which it probably isn't, it's still pretty close, and it's still way less dense than lead, so the principle is still going to be valid. The final number may be a bit different, but the logic still applies. So the density that I found for the feather is about 1.3 grams per centimeter. Oh, I was supposed to divide by that, my bad. Where's my eraser? There it is. Okay, so the mass of this feather is going to be 1 kilogram divided by 1.3 grams times the density of the air, which is still 0.0012 times 9.8 newtons. So in this case, we're going to have 0.0012 times 9.8 divided by 1.3. So what we get is just 9.0. Oh, I'm a little bit short in space. I'm going to write it down here. What we get here is 9.05 times 10 to the minus 3. And as we can see, this is greater than the buoyant force on the lead. So now we're just going to put this into our equations for the weight, this apparent weight. And in the case for lead, this is going to be the mass of the lead, which we already saw is 1 kilogram, times 9.8 meters per second squared, minus this 9.046 times 10 to the minus 3, and all of this in newtons, of course. Did I write the newtons down? Yes, I did. Okay. Well, so what is this going to be? This is going to be, wait, wasn't this, this is the number for the feathers. I'm going to correct that. This is for the feathers. We'll do lead later. Okay, so minus this. So this is basically going to be 0.9909 newtons. Wait, there's, whoopsie, times 9.8. I need to multiply this by 9.8. Okay, there it is. Something was wrong there. Okay, so this is just going to be 9.7 Newton, approximately. And in the case of the lead, we got the same 9.8 minus, but in this case, it's 1,4 times 10 to the minus 3 Newton. So when we do this, we get 9.8 minus 1.04 10 to the minus 3. So we get 9.799. I use more decimals here just to show that it does, because this was 9.70. So there we go. So as you can see, if in reality, a pound or kilogram, whatever unit of measurement you use, it doesn't matter. It's going to be the same. The same mass of feathers and lead is not going to have are not going to have the same weight because of the buoyant force acting on them, and because the feathers will need a larger volume to have the same mass as lead. The buoyant force on the feathers is going to be greater, and for that reason, it's going to have less weight than the lead. So next time someone comes at you with this trick questions and said, hey, what weighs more, a pound of feathers or a pound of lead? You can just say, haha, and ruin everyone's day with overthinking the situation. So I hope you like this. Let me know what you think of this answer to this question. And if there's anything else you would like me to overthink, just let me know and I'll be happy to do it.